So we are going in a real deep dive, okay? If you are not confident with the C++ code, you may not understand a certain point, but I will try to regain people that feel lost later on the session. So stay tuned and let's see what happens. So why two different words, NodeJS and .NET? I feel myself a techie, a geek that loves technology in general. So I don't feel to be a partisan for .NET or Node.js or C++ and so on. Doesn't matter. As far as you enjoy the technology, it's good. Every technology has good points, and why not beginning in sharing all this stuff together? That's the key point of the session. Who am I? Okay, if you were at yesterday's session, you already know I am a Microsoft MVP. You see the T-shirt, and since 14 years. Wow, it's a long time. We are, as MVP like Dennis, we are in deep contact with Microsoft. We can talk with them very openly, and Microsoft is opening more and more, so if you want to take part of the conversation, you go to github.net repositories, and you will find a lot of material that is extremely interesting, like discussing the upcoming features on the language, like C#8. Okay, there are the discussions are starting. I am enjoying several fields like manufacturing, racing with Ferrari, for example, and healthcare. It is a very, very tricky industry, the healthcare, because there are problems in performances, in analyzing images in real time, and so on. And okay, I'm a speaker, you know, and I am a trainer as well. But the pirate flag is because I give also sessions and training on security. That is something that I love so much. So, what do you mean by joining the two words? I just added this slide this night because yesterday I had a conversation at the restaurant with a guy who told me, but I can already do this by communicating with HTTP. So what's the point? The point is that the communication on HTTP means that you have to serialize the content of the object, deserialize the object on the server side, and then, yes, you can deserialize as a .NET object. That's not the point, because we all know that serializing and deserializing is costly. It takes a lot of time. It's something that we don't want to pay every single time we go from one side to the other. So I said, that's too easy. If you're a geek, you know that the solution is too easy, you discard it and say, oh, no. I want the other side. The other chance is to put all together in the same process and make Node.js and .NET live together. How is this possible? That's the core of this session. Node.js leverage the V8 Google engine, the Chrome engine. You may know or not, I don't know, but basically to execute JavaScript code, you need a kind of virtual machine, and V8 is this virtual machine. It's written entirely in C++. It's available open source in the Chromium project by Google. And the guys from Node.js had the idea to cut away all the UI part of Chrome, take just the V8 engine that is, by the way, ready to be embedded in application, so you can do it also in your own applications. And they created all the infrastructure that you may know if you use Node.js, so executing JavaScript, right? And there are many fields where you want to execute JavaScript code as a desktop application, because, for example, Electron I know that there has been a session on Electron right before mine. So it's an extremely interesting solution to create UI desktop application based on JavaScript, or TypeScript is better, on my opinion, based on Node.js. And you can leverage HTML, Angular 2, and so on. So all the things that every web developer is well known, but without the server side, just the UI, just a desktop application. And there are many cool things around V8 because it can execute the latest ECMAScript available. So there are the very new stuff. And the most important part is that you can extend V8. You can write plugins that extend the capabilities. And this is the key point. So the first part is, how can I leverage my code and simulate a JavaScript object for the moment in C++, and we will later see in .NET, because we have to start a kind of trip and first of all calling C++. And the most important, the topic is very wide, so I cannot spend too much time in 40 minutes explaining the whole V8 engine because it's very wide. So V8 has his own type system, so you have to manage the translation from V8 types to C++ types. You have to deal with it, and you have to pay a lot of attention to this because you may lose a lot of performance in copying data, of course. So there is the need to use this very wisely. And the core point is that you can wrap an object. You basically have, I want to have a class in C++, and I want to wrap this object exposing the functionalities of the C++ as it was a JavaScript object. That's the plugin that makes an object wrapping. At the initialization time, we have to declare what are the methods, the properties, the indexers that you want to map to JavaScript. It's a kind of explicit. It will not recognize automatically the members of your class. You have to instruct V8 and saying, okay, I want a method that is called this way, and when you call this method, please redirect the call to my C++ code. So it's a wrapper. And this is done by the exports. That is the main 3 point. In a few minutes, we will see what happens inside the plugin. Another point is that to ease the life cycle, all the methods are declared as static. And this is the problem, because every time you want to new something, you have to care the life cycle of the object by a kind of trick. So that's another point very important. And when you will receive arguments that you pass inside the JavaScript invocation, these arguments can be dynamic, because we know that JavaScript can specify no arguments, many arguments, and C++ is typed. So how can I can make the two words work together? All the JavaScript of the C++ code will receive just one argument that is a wrapper that contains a list of the possible arguments that can be nothing, or maybe at least a very long list of arguments. So you will have to discover that at runtime what are these arguments, what is the type of the arguments, and so on. Another key point is that you cannot distinguish between a number and an integer in JavaScript. But the V8 engine makes a difference because of performance. Because if you try, for example, in .NET, to make a loop using a double as the variable I, okay, the classic for loop, you will discover that your performances go down, 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 because you are using the floating points. While if you use integers, you are far better in performance. So the V8 is smart, and when he sees that you are using a number in JavaScript that in reality is an integer, it gives you an integer. And this is a smartness that is needed to speed up the JavaScript code. So even if you don't see it that it's really the way it works. So, the very first start is the node wrapping. And I want to show you a very simple C++ project that make use of the modern C++. I mean, oh, sorry. Duplicate, okay. Boom, 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 boom. We should, yeah. And it's modern C++. It's like C++ 14, C++ 17. It's a new ISO committee standardized the new features that makes C++ better. It's very similar to the kind of code you would see with C#, because there are no more pointers. There are smart pointers. There are no more ugly interfaces that you have to cast multiple times like in C. It's totally different language. It's a very high level, and you can really work in an object orientation fashion. So this is a calculator, for example, and my entry point, we will see in a moment. It's on the other main method. So basically, I declare the entry point with a macro, and I say, okay, my add-on have a starting point in the init, and I want to set up a hello, that is a method, called method, that is here. This means that basically when you go to code, for example, we are using Visual Studio Code, which by the way leverage Electron, which by the way leverage NodeJS, okay? And this is hello means that once you require this plugin, you basically have available the add-on, and you can call hello. You declare the static global hello methods in C++, and you can invoke directly this from Node.js. Sounds easy, right? But this is a custom code. I mean, I just write something on the console. And then I also have a calculator, and I can assign properties. I can have a getter here. I can call a method that is increment, and then I can calculate the value. And basically, what does it mean? It means that if I go step by step here, I can see step by step what is going on. And you see in the output window, hello Codefest is the message that was printed here, okay? And as you go further, you have a new calculator, and you can see the calculator constructor was called. And if I go back here in my constructor.h, that is this one, at the beginning, you see calculator constructor. Here's the calculator destructor that will be called as soon as the garbage collector of JavaScript will do the things that remove all the stuff from memory. And this is the calculator init, where I declare that I want a prototype for a method, and I declare also a few other things and in the set accessor, so that I have also a property, basically, that is called value. This means that you can go on and make set and get, you see. The getter in this case is called by code itself, because it must read the variable to give you the watches inside the watch window of the debugger. And then you go on and call increment, you see, okay? And then you have another getter, and you finally have the behavior of your plugin. That is basically the structure of what does it mean. And the calculator is a bit more complicated, because we have the object wrap that is the base class that we have to inherit in order to have the benefits of wrapping a C++ class and exposing it to JavaScript. All the non-static members are pure C++ code, and the static members are instead the entry point for V8 to call you. And you may wonder why static? Because there is no binary standard in C++. So you may expose things to the external world only as a C call. There is no standardization, the ISO committee, for when I compile a class, how do you call it? If you have seen the real name, it has several hashes and strange mangling characters, just because there is no formalization, and every compiler can generate this random number that represents, for example, the overloads. Okay, so if you have multiple parameters, you have to distinguish one call from another, and so then the names change depending of the number of parameters, of the types, and so on. So this is why the static makes it easy for Node to call you. But inside the variable that pass you, there are information that are useful to gain the instance of your object. So if you go not to the constructor, the new, but for an increment, for example, you recover this isolate, you declare a scope, and then you unwrap the calculator and gain a pointer that give you the instance that you need to increment the number. This means that you can have two different calculators, and they have different value parameters. Okay, so the instance is different. You have two different objects in memory. In my case, the JavaScript just created one, but you can have multiple just because there is this little trick. And to return a value, this is void, I just set the return value. So it's a kind of dialect for V8 to go back and give you this stuff. If I was here to explain you, okay, you should go this way, you would probably exit the room. I mean, who cares, right? You don't want to be annoyed with all this, I can call it boilerplate. I mean, it's code that is useful, but you don't want to rewrite it every time and go on and on and on. So let's go further on. The next step that we shall remember, not really important to know how it works, because it's boilerplate too. But we have to remember that Node.js requires that all the code is executed only on the main thread. Stop, like the Windows form, okay? You cannot access anything from the other threads. But there is a problem, that when you want to write, to call a .NET plugin, you are probably doing this because you want to apply a filter to an image, let's say. And that's expensive, and we know that blocking the current thread is bad. We want really what? Tasks. We want external threads that do the hard work, and meanwhile I can execute other things, and then go back and recover. The engine to manage the thread in Node.js is the libuv library that is well known on Linux, by the way, and can manage queues. Basically, it's like sending a message in the WinProc of the Windows form, if you are familiar with the Windows form. So you basically have available a queue, and when you want to execute in that specific thread, you just enqueue in that thread your message, and the key will execute for you. Okay? That's what a libuv is for. The other point is we want to execute .NET, right? But normally, when we start with .NET and we double-click on an exe created by .NET compiler, by CSC, what happens? He cares about loading the CLR itself. There is a loader, right? There is a very good article that was published a few weeks ago, like what are the 17, 18 things that the CLR do before your application gets executed. Very nice. I love that article. And you will discover that many things happen. And the first things that must go on, what is loading the CLR, the common language runtime. It's the heart of .NET. So since we are starting from Node.js, we cannot benefit of this to happen automatically, and we have to do it manually. So Again, we have to write some code that load the CLR for us. And this means that this is not the first time it happens. I mean, SQL Server does it to execute managed code inside his process, for example, okay? And this means that you have the ability to do also with .NET Framework. But we want to do with .NET Core because you can leverage what? We can leverage the cross-platform stuff. So this is so important with Node.js. And I will show briefly how it works. And basically, this means I just go step by step because it's far better, that we can go in an initialize, and I entered in too much detail. And we can, sorry, here. And we can go here, and I have a helper that is here, that basically, what's the target? I will rapidly browse here. Okay. Basically, he load library the Core CLR DLL, so we take in memory this guy. Then we get proc address, we take a function pointer for this call. Then we invoke this to have the runtime host. We authenticate the things, and then we go back because the very next call will be creating an app domain. So this is what happens inside all the initialization stuff. Then I press F5. And finally, once the CLR is up and running, we need an app domain at the very beginning. Normally, we don't do this stuff. And so we have to tell which are the trusted path, so that where can I find the DLLs, the managed DLLs that the application can load. They should be trusted, otherwise you can load untrusted code. And you specify these structures. And finally, you can create your app domain. And when the actual result is SOK, it means that everything goes well. Okay, so we exit this. Finally, we create a delegate with this helper class. Sorry, there are a couple of things that the C++ compiler shows me, but are not really important. So we create a delegate, and it's okay. And finally, once we have the delegate, we can invoke it as it was a callback function. And what happens at this point? It happens that we have on the CLR side the execution for this code. We cannot see the breakpoint actually because the debugger is native, and we should switch back, but we don't have time, to the managed debugger so that it can stop at this level. And when it arrives here, I have to marshal the pointer with the string back to the CLR word, and finally, I can print the message. So I understand that is a topic that would require an entire session to deep dive. But take the idea of the fact that we can load the CLR, create the app domain, and execute managed code. And that's very important. But again, I don't want to write all this code. I don't want to write not only managing the native code, but I don't want to use this. So what can I do? And I want to show you absolutely, before it becomes too late, the results. Do you see on the back, can you read this? Properties, let's go with a font that's like 24. Too big? No. So basically what we have the chance to create a plugin that does this for you. And what happens? That is generic. So it reads the metadata with reflection at the beginning, and then it doesn't read the metadata anymore. And use so at the beginning the new plugin initialize saying that I want to use the sample library. Then I load the class sample library in memory. So I create the app domain and load this in the app domain. And then from JavaScript, I say, okay, I want to create a new object passing these parameters. I want to create a second object creating these parameters. But this object is not JavaScript, is .NET. And you don't have to mess with the passing the parameters around and so on. You just call .NET. And you can access properties, you can copy properties, and so on. And the same is valid with methods, for example. You can load the sample library, you can create the calculator, and create and call several methods. For example, this is the execution for this other object. How the .NET method is done? So in the sample library, we have, for example, the calculator we have just seen is this one. So you don't have to map nothing special. You don't have to put attributes. You don't have to derive our special objects. You don't have to do, it's just a plain Poco library with whatever you want, right? So there is nothing that you can see. The calculator is plain C++. But the cool thing is add async. So now we have an asynchronous methods. And how can we do this stuff? This stuff will work just because there is some code that I want to show you before the execution. Async is here. That I can call like, this is the normal add, not asynchronous. This is the asynchronous, but since I don't specify any function, like I would do normally in JavaScript, I have to specify a function that get back the result. This will be executed like a fire and forget. So it's asynchronous, but I don't care about the result. Just execute it and who cares? And instead, if you call with the function here, you see that the result is and will be called back. How this magic happens? Simply because every time I see the task of T in the .NET method, I add 2 parameters to the JavaScript call dynamically, and this can receive, the first is the on success, and the second is on error. That is a typical pattern for JavaScript. And so this is the first, and the second I didn't even wrote it because it's an add. I know that it will be successful. And you can even use the Lambda version if you don't want to use the latest ECMAScript stuff. So basically, you will you see the end of the program that is called before. Why? Because the result will be called later. And I made a little trick on this, because when you say the libuv, please be careful, because I am executing something and I'm waiting a result. He suspends the execution and does not terminate the program. I didn't have to put a console read key to stop the execution and waiting back for the result. Here's something that can be done with the collaboration of libuv. And libuv will wait that you close the asynchronous operation before closing the program. And this is so nice, because it sounds really perfect. You see, the end of the program, but call it before the async results. You don't have anything else. Theoretically, it should terminate the application, right? And this is how it works. Now we have also collections. So you can iterate collection. You can have constructors. You can have events. And since events does not exist in JavaScript, I faked like the one that works in DOM of the HTML. So basically, I add dynamically the add listener so that there is a method that is used to subscribe the event because there is no language feature that gives you events in JavaScript. So add event handler here. And we go here as node x events. And you will see that I have a hash that is the subscription number. And then once the number of orders is decreased by 4, it removes the subscription and the program can terminate. So basically here you see remove, 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 and if number is equal 0, we'll remove the event handler, and finally libuv will understand that can close the process. And also we have the indexers, but they are not, it's fancy because indexers are often used in JavaScript, but basically you can imagine what they do. The whole stuff for Xcore Node is very long I cannot explain, of course, in few minutes, but it's basically what does it mean? There is an entry point, and every time you make a call invoking some .NET method, only for the first time I recognize the metadata for .NET. I read all this stuff, and I set on the exports at the very beginning. You may remember that you have to declare explicitly to Node.js what they are. So I read the metadata, I declare in JavaScript what are the members for the equivalent class. And once this is done, you don't lose no more time anymore. And the performance are pretty good, on my opinion. And I will show. I already said also the translators that I will, to Dennis, that I want to leave you all the set of slides, even if I cannot present all the stuff, so that you have something to read on. So this is basically what we did during the demos, but I prefer to put on the slides. And this is the performance profile of all the stuff. So basically what you have. The first thing I do is I want to prepare a benchmark, because you know the first execution is not something that is relevant from a benchmark perspective. And you may know that JavaScript get compiled. Okay, V8 does compile JavaScript. It's not executed, just interpreted. That was the old times, 20 years ago, but now it's totally different. So the function that I have here is an add. Benchmarking an addition is a kind of suicide, you know, because it's the most easily optimizable code. So this is the worst case ever. You should never call anything externally that does an add. Doesn't make sense, right? But I want to test this because testing an addition means that you are testing the infrastructure. It's pretty much the same. So the worst case possible, this local add is so simple. And this one is the add that I created just in C++, pure code in C++, that makes the addition and return back. While the local add, that is this one, is the code in JavaScript, so only JavaScript. And the xcore.add is instead my generic plugin. So I had to deal with all genericities, recognize the metadata, do all the stuff. And as you can see, the 6 milliseconds for JavaScript is the best time because it's compiled. And once you go, even just only in C++, that is considered the most powerful from the performance-wise, you, of course, incur in marshalling, because V8 and JavaScript have and C++ has different type system. So you are paying something. And this something in C++ is 10 times. It's relevant, okay? And when you go outside, there are 4 marshalling parameters, because you have to go from JavaScript to V8. From V8 you have to go to C++. From C++ you have to go to .NET and finally invoke the call. And when you have a result, you have to do exactly the opposite and go back. So it's very expensive. But if you think that we have in 1.2 seconds for this pre-release code, 1 million call, I am more than satisfied. Okay? So this is basically the performance-wise. If you invoke a call that, for example, apply a filter on a JPEG, doesn't care. I mean, this is zero cost, right? It depends on you. Of course, you should not use this to make additions on the calculator because it's pretty stupid. The most important use case that I just ran the demo and then I finish is the one with Electron, where I can have, this is in debug mode just to show you the things, and you can see that a lot of debugging stuff are occurring on the Node.js side, and the content of this is by a managed class, a .NET class called the quotes, which expose a collection. So you can bind JavaScript and Angular 2 content to .NET. You have a collection in .NET, and you simply say, okay, my quotes, I want to bind them to the Angular 2 tags that are available on Electron. And that's so cool. I mean, I will probably be happy by myself, but I mean, if you see code for this, that's the binding. And orders is something exposed in .NET. And the actual code on TypeScript, you can recognize loading the sample library, the quotes library, and then you just have the loop to fill the array and nothing else. So, many use cases. I am interested in having feedbacks. I published this project on GitHub to take feedback and on NPM registry, so the binary is available to play with. If you have questions, you can join me at the Ask the Expert zone. And I want to thank you. Sorry if I went so fast, but the argument is really deep. I hope you enjoyed the session. Thank you very much.
So we have time for one question, for one or two questions. Who want to ask? Yeah.
Hi.
Hey.
Thanks for presentation. What happened when you think, well, I need to mix .NET and Node.js? I mean, was it a real case, a real life case?
Oh, so one night I had a nightmare, and then no, just joking. The real case, for example, just the Electron one, and there are a lot of cases where you need a front-end language that is dynamic, just because you have to change few things in production. So there are many persons that are more familiar with JavaScript than C#. They don't want to recompile the code. They don't want to take this as a kind of scripting of the .NET part that you can do also with the new C# and Roslyn stuff, but it's a bit harder. It requires you to do other things. And you can think also to a kind of replacement of PowerShell, if you will. It requires a bit of additional work, but the idea is that if you're familiar with JavaScript, you can basically create scripts to administer your network and do whatever you want, because the .NET can give you the power to access to service controllers, to the pings and so on. So it's just an idea. I would like to know if you believe it's not useful okay, that I take this point. My main point is to go to the Electron part because I believe it's a very nice desktop framework, but there are many other cases.
Thank you.
You're welcome.
Will there be any possible issues with garbage collection? For example, I create the object in JavaScript environment, but I want to reference my any managed objects in .NET environment, and
yeah, you're right. There are possible issues. Basically, what I'm doing, because I am still working on the life cycle, is that on the managed part, I have a manager for life cycle of the objects, and I want to have the callback from the JavaScript garbage collector so that I can remove the object on the managed side. So I want to tie all the life cycle to the garbage collector of JavaScript because it makes sense. I mean, the library is just a library, and since the references are held by JavaScript, you should continue to give JavaScript the power of deciding when they will be released. Once you release from JavaScript, it will be up to the garbage collector in .NET to really release the memory. That of course, you can just null your reference. You can do nothing else. In theory, it will be possible also to speed up all these operations by forking the Core CLR source code and to marshal directly in the Core CLR. But it's, I mean, if there is a requirement, yes, it's possible, but I mean, it's hard. It's definitely possible, but there should be a very strong reason to do this. The cool part is that the sources code are there. There are many forks for people experimenting strange things. So, yeah, it's technically possible and also legally possible. That's the cool part. That's why I enjoy .NET Core, because Microsoft gave me the opportunity to do this. Otherwise, we close the source, I should hack something. But it would be not an hack. It will be normal coding.